Okay, so zeros of polynomial functions, and we're looking to find the real zeros of polynomial functions. So the first one we're going to look at are the rational zeros. So we need to know the difference. So rational zeros, so these are zeros that can be written as a fraction. So f of x is equal to 3x squared plus 7x minus 6. Now we can factor this, and this could be written as x plus 3 and 3x minus 2. And then the rational zeros, there's two of them. And this is x is minus 3 and x is equal to 2/3. So 3 over 1, 2/3, they can be written as fractions. Then we have our irrational zeros. So an example, so we use g of x is x squared minus 5. So if we were to factor, we would have x plus root 5 and x minus root 5. So these are the two, so there's two irrational zeros, and these are at plus and minus root 5. So we're going to use the rational zero theorem. So we're going to list all the possible rational zeros, or all the possible zeros from our function using p divided by q, and q is going to be the leading coefficient. And we're going to take factors, and p is our constant term. So we have a function, and we said we look at the leading coefficient and the constant term. So the leading coefficient we're going to call q, and the constant term we will call p. Now to use the rational zero theorem, we need to list all the factors. So we're going to list all the factors of q, and then we're going to list all the factors of p, and we're going to rewrite them in the form, and then rewrite so they're in the form p divided by q. So if we look at the leading coefficient for q, we have a 2, so we want all the factors of 2. So this is going to be plus or minus 2 and plus and minus 1. Now if we look at all the factors of p, we have a 3, so this is going to be plus or minus 3 and plus or minus 1. And rewriting them as p divided by q, so all our p values, so we have plus or minus 3 and we have plus or minus 1, and these are going to be divided by plus or minus 2 and plus or minus 1. So we just need to write all the possible combinations. So we have, so p divided by q, so we could have plus or minus 3 divided by plus or minus 2, and we could have plus or minus 3 divided by plus or minus 1, and then we could have, let's write this first, so this will be plus or minus 3 over 2, or we'll have plus or minus 3. So these are our two options here. And if we wrote the 1, so we'd have plus or minus 1 over plus or minus 2, or we could have plus or minus 1 over plus or minus 1. And this would give us plus or minus a half or plus or minus 1. So these are our 4 possible roots. So I'm asked to list, so list all possible rational roots or zeros. We would have plus or minus 3 over 2, plus or minus 3, plus or minus a half, plus or minus 1. So now we need to test to see if there are any zeros. So when we look at our function is squared. So we know that there is going to be a maximum of 2 roots. So we're going to use synthetic division, and we're going to test to see. So we're going to divide by our roots here. So we're going to see, first of all, I'm going to choose a 1. So I'm going to bring down 2, 7 and 3. And the last is our remainder column. So if I bring down a 2, 2 multiplied by 1 is 2, 7 and 2 is 9, 9 multiplied by 1 is 9, and that's 12. So x minus 1 is not a factor. So that means 1 is not a 0. So I'm going to try minus 1. So 2, 7 and 3. So bringing down the 2, 2 multiplied by minus 1 is minus 2, 7 minus 2 is 5, 5 multiplied by minus 1 is minus 5, and this is minus 2. Remainder is not 0, so x plus 1 is not a factor. Okay, so this is how we could test to see if we have any zeros. So if I was to try minus 3, so bringing down the 2, 2 multiplied by minus 3 is minus 6, 7 minus 6 is 1, 1 multiplied by minus 3 is minus 3, and 3 minus 3 is 0. So the remainder of 0. So we know that x plus 3 is a factor, and minus 3 is a 0. So now we have what we're left with is 2x plus 1. So 2x plus 1 is a factor. So we also know that this is a factor. And if we solve this, this is 2x is equal to minus 1. So x is equal to minus a half. So minus a half is also a 0. So we know for the function of f of x, 2x squared plus 7x plus 3, that x plus 3 and 2x plus 1 are factors, and we have 2 rational zeros at minus 3 and minus a half. And we can graph this to confirm. Okay, so putting our function into a graphing calculator, and then looking at the graph, we can see that we have our zeros at minus 3 and minus a half.